Hi there, and welcome to the Intro to Science PowerPoint lecture. We've got some key ideas that we're going to go over and discuss in this first section. So our first is, how do scientists explore the world? Second, how are the many types of science organized? And then third, why are scientific theories and how are they different from scientific laws? So first of all, how do scientists explore the world? Well, scientists may perform experiments to find new aspects of the natural world, to explain a known phenomenon, to check the results of other experiments, or to test the predictions of current theories. So, again, scientists investigate, they plan experiments, they observe, and they always are going to test the results. So how many types of science are there and how are they organized? Well, there's different categories. There's lots of smaller branches of science. Natural science is broken down into three main categories. We've got biological sciences, we've got physical sciences, and earth sciences. And we're going to focus our attention on the physical sciences. So first semester we're going to talk about chemistry, and next semester we're going to talk about physics. Just to get a general definition of science, this is the knowledge obtained by observing natural events and conditions in order to discover facts and formulate laws or principles that can be verified or tested. And then science and technology can work together. So science, we can find the continuing search for scientific knowledge. And then advances in either science and technology do have some dependence on each other. And then finally on this slide we've got technology, which is just the application of those sciences that we can apply to practical purposes. The next slide is an important topic to differentiate between scientific theories and scientific laws. So in general, theories explain why something happens, and then laws explain how that something works. So again, we can define law as a descriptive statement or equation that reliably predicts events under certain conditions. Whereas a theory, a system of ideas that explain many related observations and is supported by a large body of evidence acquired through scientific investigation. Another note we might be able to put in here are hypotheses, which are just an if-then statement when we're trying to figure out if X is a resultant to Y. And then I also want to make a quick note about theories. There's a common knowledge theory, and then there's the scientific use of the word theory. Typically out and about, the common use of theory, we think of it as like an idea. It seems to carry the more hypothesis definition, whereas in science, a theory is actually something that is a sound explanation. So we have a large body of evidence that supports that idea or theory. Again, experimental results are going to support laws and theories. And even though we have theories that are supported by all this evidence, they're still being questioned, they're still being looked at, and we want to make sure that it is still sound with our current understanding, current knowledge of the way things are, the way we see things. So to be valid, a theory has to carry three items. It has to explain observations, it has to be repeatable, and then it has to be predictable as well. Nextly, we're going to mention mathematics really quick, and we can use math to describe physical events. One of our first uses of math this semester is going to be dealing with density, and that's looking at how an object's mass, how much of that substance there is per its volume. Okay. So we have two different terms here. We've got qualitative statement, which describes something with words. We can describe something as green or orange, so we can describe the color, we can describe the smell. Basically, the way it looks is a qualitative statement. We can also have a quantitative statement, which describes something using mathematics. Say we've traveled 12 meters. You can say I've got a gallon of milk. Those would be quantitative statements. Again, theories and laws are always being tested. And then we can use models to represent those physical events. So a model is a representation of an object or event that can be studied to understand the real object or event. And then as scientists, we can use conceptual models, physical models, or computer models to study objects and events. And we use these models in everyday life, and we tend to use models for being able to observe things that are really small. So we've got atomic models that we'll use in this class to look at something really small. We'll make it bigger so we can look at it more closely. And then we can use models for extremely large things as well. An example I can think of would be to the solar system. So we're going to use smaller models to show that larger item. Thanks for listening.